This is section 6.4, factoring special products. Let me show you the first formula you're going to be using on this section. And this is the difference of two squares. And whenever you have the difference of two squares, it factors into the following, which you see here. And the next formula is the formula of sum of two cubes. When you have the sum of two cubes, it factors into the following. Notice that on the first formula, it's a binomial times binomial. On the second formula is binomial times trinomial. The next formula is the difference of two cubes. And just like the second formula, is a binomial times a trinomial. Now, if you were to take the time to actually FOIL this, you're going to notice that you get the following. If you multiply this binomial times this trinomial, which you have done in the past, an earlier chapter, you're going to notice that you're going to get this binomial that you see here, and so forth. Okay. So now let's apply these formulas. Let's go to number 1. So it says factor completely if the polynomial is prime, state so. So I'm basically going to apply the x process, which you know that I'm going to be using 12 and 36. So I'm looking for the two numbers that satisfy these two conditions, which are 6 and 6. So then I get the following. Either x plus 6 times x plus 6 or x plus 6 squared. Look at number 2. I have this trinomial. I am going to apply the x method. Negative 20. And notice that in this case, I need to multiply. Since the coefficient here was 1, I get 36. So 1 times 36 is 36. Here is now 1, so I multiply 25 times 4, and that's how I get 100. And we have done this on the previous section. Just a quick review. But anyway, now I'm looking for two numbers that satisfy these two conditions. The sum of negative 20 and the product of 100 turns out to be negative 10 and negative 10. And then I'm going to rewrite this trinomial as a polynomial with 4 terms. And then at this point, grouping, group the first two, group the next two. Common factor out of the first group is 5a, out of the next two is negative 2. You have done this in the past. You pull out the 5a minus 2 out of the two terms, and you end up with 5a minus 2 times 5a minus 2. Or you can express the answer as 5a minus 2 squared. Let's go to the next slide. So now, this is number 3. I'm going to apply the x method again. So notice that in this case, I can rewrite this if you don't see why we have a 0 here. This is the same thing as n squared plus 0n minus 81. So that's why you see the b is a 0. And the c in this case is negative 81. So two numbers that satisfy that are 9 and negative 9. So and then I go over here, and this is what I write as my first binomial, second binomial. And if I was to take the time to FOIL this, you notice that you get the following. Another way that you can do this problem is by simply recognizing that this is the difference of two squares. N squared is a perfect square, 81 is a perfect square, and there's a difference of them, so that's why it factors into this. This is the first formula that I showed you on the first slide. I actually like this process better because the more formulas you memorize, the more likely you're going to forget. This process you have been using quite a few times when you factor. So here we go. Let's go to number 4. So again, I apply the x method. The middle term is also 0. You can rewrite this as 16x squared plus 0xy minus 25y squared is equivalent to what you see here. That's where I get this 0. You know where the negative 400 comes from. 16, negative 25. Two numbers that satisfy that are 20 and negative 20. So then at this point, I rewrite this, since the leading coefficient is now 1. This binomial as a polynomial with 4 terms. So this is what I get. Apply the process of grouping, group the first two, next two. This is what I get. Pull out the GCF, which is 4x minus 5 out of both of them. This is what I get. Or you can also do this problem by simply recognizing that this is a perfect square, which is just 4x. This is a perfect square, which is 5x, 5y, and this is, that's why this is 16x squared is a perfect square, because it's the same thing as 4x raised to the second power, and then 25y squared is the same thing as 5y raised to the second power, and you have the difference. Ignore this part right here. And then if you apply the formula, you should be able to see why we get this. The formula you saw on the first line. Let's go to number 5. So this is different. Notice that here you have the sum, and you also have m cubed. Recognize that you're going to have to apply a different formula. The formula you're going to be applying is going to be this one. Why this one? Because this is a sum, and this is a cube. This is also a cube. And you're going to see how we can rewrite 27 as a base raised to the third power. But once we recognize that we're going to have to use this formula, this is what I'm going to do. I'm going to rewrite, this one stays the same, but I'm going to rewrite 27 as 3 cubed. Why am I doing this? Because this is going to represent my a in the formula, and this is going to represent the b in the formula you see here. So now from here, I am actually going to write this in factor form, but I'm going to first express the binomial, and then I'm going to express the trinomial. So here we go with the binomial. According to the formula, the first term in the binomial is whatever a is. So in this case, the a is just the m. That's why you see m there. And then it says plus, so I bring over the plus whatever the b is. In this case, the b is 3. So I'm done with the binomial. Now I'm going to do the trinomial. According to the formula, it says whatever the a is, square it. The a is m, so if you square m, you get m squared. Bring down the sign of minus, and then just a times b. And we know that a is just m, and we know that b is just 3. So the answer here, what I'm going to write down is negative 3m. Continue with plus. The formula says plus, and then whatever the b is, and you square it. The b is 3, so I square it. So that's why I get plus 9. And then this is one extra step that I'm going to encourage you to make. Excuse my English, but you get the point. All I'm going to do is I'm basically going to multiply this, because I want to multiply this and I want to get the original binomial that I have here. So here we go. So what I'm going to do is I'm going to multiply m times the trinomial. Once I do that, notice that I get m times m is m cubed, m times negative 3m is negative 3m squared, m times 9 is 9m, and that's what you see there. Now, and you have done this on earlier section, so now you know why we do stuff on previous sections. It comes up on a future section. This is the way the math works. Anyway, at this point now I'm going to multiply 3 times this trinomial. So I'm going to distribute the 3 times all these 3 terms, and this is what I get. Notice that I line them up, because from here you should notice that these cancel out, these cancel out. So if I was to check my work, if I multiply these 2 polynomials, I should end up with the original binomial, and I do. So it checks. Let's go to number 6. Very similar to number 5, but notice that I have a minus. So this should kind of give you an idea that you're not going to be using this formula, and you're going to be using this other formula, which is the difference of cubes. So my next step is to rewrite this as a base raised to the third power, and the same thing as a base raised to the third power. And this is something that you should be able to follow, because we have used this on an earlier section, rules of exponents. 3a to the third power gives me the following, 27a cubed. In the same manner, 4b to the third power gives me this. Bring down the minus. So now, this is going to represent my a, and this is going to represent my b. And then I'm going to use the formula to factor this binomial. So first, I'm going to express the binomial. The formula says just basically write down what the a is, which in this case is 3a. And then bring down the sign with a minus, and then write down what the b is, which is the b is represented by 4b, minus 4b. I continue with the formula. The formula set. Now I'm going to write the trinomial. The first term in the trinomial is whatever the a is, square. So 3a is the a. I square that and I get 9a squared. And then whatever is plus the product of a times b. So 3a times 4b. That's what the formula says. And this is what I get. And then the last term of the trinomial is whatever the b is, which is 4b squared. So 4b squared, you should be able to follow that is equal to 16b squared. And don't forget the sign. And again, if you take the time to check your work to make sure that if the product of this binomial times this trinomial gives you the original answer, you will be certain that you have the right answer. So let's do that. Multiply the first term times the trinomial. I get this. I'm not going to go through it, but you should be able to come up with the following. And then at this point, I'm going to multiply the second term of the binomial times the trinomial here. And this is what I get. And notice that these cancel out. And my answer is 27a cubed minus 64b cubed, which is the original binomial. So it checks. Let's go to the next slide. So here's number 7. Notice that this one looks a little bit different. And the reason for that is because first you should recognize that there's a common factor of 5. Before you even begin doing anything, pull out the GCF of 5. So this is what you get. From here, now this is starting to look more like the difference of cubes. So you know that you're going to have to use this formula. So the next step is to rewrite this term as a base raised to the third power, and the same thing here, base raised to the third power. And this is what you get using some rules of exponents. Bring over the 5. And again, just to quickly check, excuse me, 2x raised to the third power is equal to 8x cubed. 3y squared raised to the third power, you need to know your rules of exponents. You end up with 27y to the 4, 27y to the 6, and bring over the sign here. So now I recognize that this is going to be my a, 2x. This is going to be my b, 3y squared. So then I apply the formula. First, I'm going to write the 5, and then I'm going to write the binomial. The binomial is just 2x minus 3y squared. 2x minus 3y squared. Now I'm going to write the trinomial. So whatever the a is, which is 2x, I'm going to raise it to the second power. That's why you see 4x squared. Then plus, and then the product of a times b, 2x times 3y squared. That's why you see 6xy squared. And the last term in the trinomial is just whatever the b is squared. So the 3y squared. And again, you need to know your rules of exponents, and that's why you should agree with me that we get 9y to the 4th. Take the time to actually check your work by actually distributing this binomial times the trinomial. If you multiply the 2x times the trinomial, this is what you get. The second term in the binomial times the trinomial. This is what you get. And notice that these go away. Excuse me. So these go away, and this matches the original binomial they have inside the parentheses. And then if you multiply this by 5, you end up with the original binomial. So here's number 8. You look at number 8 and try to see if there's any GCF that you can pull out, and you notice that there's none. So this gives you a hint that this is going to probably be difference of cubes, and this is the formula that you're going to be applying. So your goal is now to rewrite this as a base raised to the third power, the same thing here. And by you using the rules of exponents, this is what you get. M cubed raised to the third power is equal to m to the 9th. 3n squared raised to the third power, you get the following. So then I apply my formula, but first I know that my m cubed is going to be my a once I plug it into my formula, and my 3n squared is going to be my b. So let's write out the first polynomial, which is this binomial. So whatever the a is, which is m cubed, put it there, minus whatever the b is, so it's negative 3n squared. We're done with the binomial. Now let's write the trinomial. A cubed, so whatever the a is, raised to the second we raise to the second power. So m cubed raised to the second power, we get m to the 6th, plus the product of these two, whatever the a is and the b is, and this is what you get, and then plus whatever the b is, which is 3n squared, and I take the b and I square it. So I take 3n squared and then I raise it to the second power, and I get plus 9n to the 4th. At this point, just by checking, this will let us know if you have the right answer. So I'm going to multiply the first term of the binomial times the trinomial. This is what I get. The next term in the binomial times all the terms in the trinomial. And this is what I get. And then I go ahead and simplify, and it matches the original binomial. Next one. So here's number 9. I'm going to be skipping some steps, but you should be able to follow. Here's the problem. Before I begin, I notice that there's a common factor here that I can pull out, the GCF. Once I pull out the GCF, it should be very obvious to me that I'm going to be working with the difference of cubes. So this is the formula. So my goal is now to rewrite this as a base raised to the third power, base to the third power, and this is what I get. Using the rules of exponents, 2x, raised to the third power is that, 3 cubed is that. Apply the formula. Again, this is my a, this is my b. When you write the binomial, you have a minus b, and then the trinomial. This is what you get. Don't forget to bring over the 2x squared. And again, if you take the time to multiply this binomial times the trinomial, you should end up with this binomial. Let's go to number 10, which will be the last problem. Again, before I begin to do anything, I notice there's a common factors, so I pull out the GCF of xy cubed. From here, this tells me that I'm going to have to use the sum of cubes. I can express this as base raised to the third power, same thing with the 216. So this is the formula that I'm going to be using. If I express this as a base raised to the third, base raised to the third, this is what I get. Then from here, I apply my formula. This is my a, this is my b. I plug it into the formula. This is what I get. Don't forget to bring out the xy cubed. If you were to take the time to FOIL, not to FOIL, but to multiply this binomial times this trinomial, it should match this binomial. And this is the end of the video.